Hey, hi, Rajan this side. Welcome to my YouTube channel. So today we will discuss all the four problem asked in today's LeetCode Biweekly Contest 162. So let's start with the first problem. So it says you are given two categories of theme park attractions. One is land ride and one is water rides. Now each of the rides have two information: start time and duration. And a tourist must experience exactly one ride from each category. So it could be either first water and then land ride, or it could be first land rides and then water rides, right? And they can start at any moment or later moment, that is fine. If the ride is started at time t, it will finish at t plus the duration of that ride. Okay. And immediately after finishing one ride, the tourist may board the other if it is already open, or it will wait until it open, because each of the rides have a start time, so you may have to wait until it gets open, right? And ultimately you have to return the minimum, the earliest possible time at which the tourist can finish both the rides. Okay. Let's look at the explanation part. So in the problem, we have to follow exactly one ride from each category, right? And they could be in any order. So, and one more thing, in the first problem, the constraints are only up to 100, right? So we can easily use two while loops, right? So let's say we use first while loop for land, for all the land rides, and we use the second while loop for all the water rides, right? Water rides. So let's say like you chosen land ride I and water ride J, right? So, and one more thing, we can, like we can experience this in any order, right? It could be either first land and then water, or first water and then land, right? So let's take one case. So let's take a case when we are doing land first and then water second. The other case is just vice versa of it. So if you understand this case, you can quickly write a code for the second case. So now let's take a case when we are doing land right first and then water right? So there are two information given. For each ride we are given the time when it start and the duration, right? So let's say for land ride, your time is LT and LD. Now for water ride, let's say your time is WT and duration is WD, right? So there there is only one case possible. Like essentially two case. Let's say since you're doing land ride first, so your first land ride would finish at time LT plus LD, right? You started at T, you will wait until it get finished for the duration LD. So LT plus LD is your duration. Now, if that is less than or equals to the start time of your water ride, right? If that is the case, it means that you have to wait until the water ride finishes, right? So let's say your this time is like your land ride started at 1 and the duration is 5, right? So it will start at 1, it will wait for 5 seconds until it get finished. So now the time becomes 6. At 6 it will finish. Let's say your water ride start at time 8, right? So you have to wait for 2 seconds. This is the wait time. You have to wait for 2 seconds until your water ride starts. So in this case, what will be your final time when the water ride finish? That would be start time of water plus the duration of water, right? So this is your answer. If your LT plus LD is less than the start time of your water ride, so in this case you have to wait until the water ride start. Now otherwise, if that is not the case, so it means that let's say this is 1, this is 5. Now let's say this is 3. So you started at 1, you finish it at time 6 after doing your land ride for 5 seconds. Now let's say by the time your land ride finishes, your water ride already started, right? So it means that you don't have to wait until because it is already started. So you just have to um follow this duration WD, the duration of your water ride. So in this case your answer would be LT plus LD plus WD. So this is the time when you finishes your land ride, and immediately after that you follow the water ride, because you don't have to wait any second, because that is already started. So water is already started, right? So yeah, that's all. So this is the answer for the first case when you started land right first and then water right. The second case would be just vice versa of it, right? So yeah, that's all about this first problem. Now let's see how we can write code for it. This is code of first. This is the code of first problem. So you are given land start time, land duration, water start time, water duration. So n is the length of your land rides, m is the length of your water rides. Initially I took answer as a maximum max because ultimately I have to find out the minimum possible duration to finish both the rides, right? So I use two loops. So I'm going through all possible combinations of pair of rides. So one for the land and one for the water ride. So let's say you took ith land ride and jth water ride. So what will be your LT? I mean, the start time of land ride would be land start time I, duration similarly for water ride, start time and duration. Now we have to follow two cases, right? The first case is that when you are doing land ride first and then water ride, and the second case would be when you are doing water ride first and then land ride. So if you're doing land ride first and then water ride, this is the same case what I have explained in the explanation part. If your LT plus LD, start time plus the duration, I mean ultimately when it finishes, if this finish is less than or equals to the water start time, your answer would be WT plus WT. Otherwise it would be LT plus LD plus WD, right? So this is the case when you have to wait until your water ride start, and this is the case when you don't have to wait. So you can immediately start your water ride. And in the reverse case, if you are following water ride first and then land ride, so in this case you have to check if your WT plus WT, the time when your water ride ends, is less than or equals to the start time of your land ride. If that is the case, your answer would be the time when your land ride finishes, right? LT plus LD, start time plus duration of your land ride. Now the else case, if that is not the case, then you don't have to wait for land ride to start. That is already started by the time you finishes your water ride. So your answer would be WT plus WD plus the duration of your land ride, right? And at the end return your answer. This is code of first problem. Now let's look at the second problem. This is the second problem asked in today's contest. So it says you are given an integer array nums and integer k. Now this array is called balanced if your maximum element in the array is at most k times the minimum element, right? So your max element should be less than or equals to k times the minimum element, and you may remove any number of elements from the given array nums without making it empty. Now you have to return the minimum number of elements you have to remove so that the given array become a balanced array, right? Like for example, you are given 2, 1 and 5 and k is equals to 2. So if you see here, your max element is 5 and minimum element is 1, and mean element into k, which is 2. So your max element is greater than minimum element into 2, right? 5 is greater than 2. So you have to remove one element, right? So once you remove 5, so we have to remove 5 here. So now your array become 2 and 1. Now the max element is 2, mean element is 1. Now max is less than or equals to mean into k, right? And which is 2 essentially. So your answer become 1. 1 is the maximum element, I mean the minimum number of element which you have to remove. So we just have to remove one element, which is 5, and your answer is 1. We just have to remove one element to make the given array balanced, right? So yeah, let's see how we can solve this problem. In the second problem, we are given nums array, right? This is your nums array, and we have to make this array balanced, right? And the definition of balance is that your max element is less than or equal to k into mean element. So see, we have to play with the mean and max, right? So it is always optimal to sort first. Right? So once you sort the given array, your minimum element would present at the beginning and your max element would present at the end, right? So we will check if your max is less than or equals to k into mean. If that is true, then you don't have to remove any element, just your answer would be 0 in this case. 0 means you don't have to remove any of the number, because your given array is already balanced. if that is not the case, if your max is greater than k into mean, right? Now in this case, to make the array balanced, the most optimal approach would be to remove few elements from the start and few elements from the end, right? Like it could be either all from start, all the elements, all the removed element could be from end, or it could be a combination of like few from start, few from end. So let's say you removed z number of elements, right? And after removing z number of elements, your array become balanced. So once you remove z number of element, now the size of this array would be n minus z, right? And one more thing, this would be a sub array, because since you remove few from start, few from end, so this, the remaining array is a sub array, which is a like contiguous part of the array, and the size would be n minus z. So see, just observe one thing. If for this z your array is balanced, right? If you remove z number of element, your array is balanced. Can I say, if you remove z plus 1, z plus 2, z plus 3, can I say your array will always be balanced? Because see, they are in a sorted form. For like, so if you remove z number of elements, your array is balanced. If you remove more elements, your array will again be balanced, always be balanced, right? So if you draw it on a number line, it would look like, let's say for this g, your array is balanced. Like we can clearly see, if you remove more element, your array would still be balanced. So for z plus 1, z plus 2, z plus 3 and so on, your arrays will be balanced, right? And let's say this is a critical point. This is a critical point means before that, let's say your array is not balanced. Can I say for z minus 2, z minus 3, your array will still not be balanced? So see, this is a monotonic behavior. Up to certain point, your array is not balanced, and after this point, your array become balanced. Means for these many number of removed element, your array is not balanced. But once you hit this point, this G point, this critical point, your array become balanced. And once you remove more element than this critical point, your array is still be balanced, right? So this is a standard kind of how the binary search looks like. I mean, how we can apply binary search in this kind of problem. So this is a monotonic behavior, right? So this is all 0 0 0 0 0 0 0 0 0. This is 1 1 1 1 1. So right, we can use a binary search to find the first point where you get this one, right? Yeah, so this is all about the explanation part. Now let's look at the code. This is the code of second problem. This is the size of the given array. I initially sorted it. This is my low, this is my high. So low means the minimum element which you can remove, which is 0 for the case when the given array is itself balanced. So in that case you don't have to remove any element. So the low is 0. High is n minus 1, because if you have a single element in the given array, that is already balanced. So at max you can remove n minus 1 number of elements. This is my answer. Initially I took it as n. And this is a standard binary search implementation. Low is less than or equal to high, and I took mid. So mid is essentially your z. Z is low plus high minus low divided by 2. So in this case I'll be removing z number of elements. See, and like if you have followed the explanation part, you know that you may remove few element from the start, few element from the end, right? So it's better to follow all the subarrays once you remove z number of elements, right? So now once you remove z number of element, your length would be n minus z, and this OK essentially tells you that if you get a subarray which is balanced once you remove z number of elements. So I'm going through all possible subarrays of size len, of length len, right? So I'll be going through all possible subarrays. So this is my minimum element, this is my maximum element. I just check if your max is less than or equal to k into mean, right? Because this is the case, like if this satisfies, it means that your array is balanced. If you get any of the subarray which is balanced, your OK would be 1, right? Now after this for loop, I just check if you get a subarray which is balanced. If it is true, we don't have to go for larger z, right? Because for this z, if you get a subarray which is balanced, if you remove more elements, it's anyway like like so it will always be balanced. So like you don't need to remove more element. So right, that is why I updated the answer and I updated the high value, because I don't want to remove more element. So high would be min minus 1. But the if condition, when you didn't get any subarray which is balanced, now you have to remove more elements, right? In that case you have to update your low value. So once this while loop once this binary search calculation finished, you can return your answer. So yeah, this is the code of second problem. Now let's look at the third problem. This third problem is exactly same as the first problem. The only difference comes in the constraint part. So in the first problem, your maximum size of array possible was up to 100, right? So we were able to write a code of complexity n into m. But here the max size could be up to 5 into 10 to the power 4. So we cannot write a code of complexity that high, right? So we have to find a solution which is more optimal. So we have to try to find the solution up to maybe order of n log n or order of n. So solving this problem in order of n, it's pretty hard. I don't think it's possible, but we do have a solution to write to solve this problem in order of n log n, like using binary search and prefix and suffix array. So yeah, now let's jump to the explanation part. So in the problem, we know that your order could be anything. Like it could be either first land and then water ride, or it could be either first water ride and then land ride, right? So I'll create a same function, but in the second pass, I will just swap these two arrays, right? So it will cover both the cases, to have first land then water, and then first water and then land, both the cases, and we will take the minimum among these two, right? Now consider a case when you are doing land ride first and then water ride, right? So we know that we have n number of land ride and m number of water rides, right? So we will go through all possible land ride and we will try to find which water ride is the most optimal. But here, so in the first solution, if you notice, we gone through all possible land and all possible water rides. But here we won't do that. We will go through all possible land exactly same as the first approach. But here, instead of going through all possible water ride, we will try to optimize it using binary search. We will try to find the most optimal water ride to choose for the given land ride, but in an optimal way using binary search. So let's see how we can apply that. So we will first start from I equals to 0, I less than n, I plus plus, right? I plus plus for all the land ride. So let's say this is your land ride, land I. Let's say you choose this land I as your land ride. So it will have two information: your land start time and this land ride in time, not in time, the duration, ls and ld, right? So the time when this land ride would finish would be ls plus ld, right? Now what I will be doing, we have this water ride, m water rides, right? And each water ride again will have the water ride start time and water ride in time, sorry, not in time, the duration, right? I will first sort all this water ride in the ascending order. So your start time of your first water ride would be less than or equals to start time of the second water ride and third water ride and so on. So first sort the water ride. So first sort all the water rides, right? Now I will search. I will one thing. Once you sort it, let's say this is your water ride, right? After sorting, I will search which water ride has start time less than or equals to this and which one has more than this. So let's consider this is your j, where the start time of this water ride ws of j is greater than this let's say this is your finish. This is your finish of your land ride. This is more than the finish. And all these, I mean, before j, your ws of the start time of these rides are less than or equals to finish, right? So in this case, what will be your answer? Your answer would be finish plus, see, all these water rides which are like whose start time is less than the finish time of the land ride, these are already started, right? So you don't have to wait for it to start. So you just have to find the minimum value of WD in this half. In this half, you just find the minimum water ride, and like the minimum duration of the water ride. So this would be minimum of WD. This is the answer in this case. In this case, when all the, like, so before j, and for all the water ride whose start time is more than the finish time, so this is the case when you have to wait until your water ride starts, right? So in this case, your answer would be minimum among w, your water start time plus water duration. So in this case, you have to find out the minimum among all possible j's from j to m minus 1, right? We have to find out the minimum, so we have to wait until it starts. So once it is start, this is the start time, and your, I mean, the moment when this whole rides would be finished would be ws, the start time, plus wd, right? So this is the case when your start time is less than your finish time of your previous land ride, and this is the case when your start time is more than the finish of your land ride, right? So yeah, now to implement this, there are two things required. There are two things important, right? One is to find the minimum of, I mean, the minimum duration, like in this range. This will be done using prefix array. I would highly recommend to learn prefix and suffix, like how to build the prefix and suffix arrays. Now this information will be done using storing information in a suffix array. So suffix of I essentially tell you the minimum from I till m minus 1, the minimum value of ws plus wg from I till n minus 1, and prefix value of I essentially give you the minimum value of your wd, the duration of the water ride, from index 0 to I. So yeah, this is your, so we have to build up two arrays. One is the prefix array, one is the suffix array, and we can use these two information to optimize the solution, right? So yeah, this is the, like, this is all about the explanation part. Now let's see how we can write code for it. This is the code of third problem. So if you have noticed, we are given 4 arrays in the problem, right? 2 for land and 2 for water. So I actually created a function, a solve function, which essentially takes, like, consider first vector as a first ride and the second past vector as a second ride, and that is why I had to call this function 2 times. One as a land ride first and one as a water ride first, right? And I took the minimum among these two. Now let's consider a case when you are doing this first, I mean the land first and then water. So this is your n, this is your m, the size of land and water rides. This is my answer, int max, because I have to find out the minimum time, right? So yeah, now coming to few pre-calculations. So in the explanation part, I mentioned that since you are considering water as a second ride, we have to store this in some vector, and then we have to sort it based on the start time. That's exactly what I have done here. This is my water ride. So water ride essentially takes start time and the duration, and then I sorted it. So this sorting will be based on the start time. So the first ride would have the smallest start time, and then the second element, like the second right would be the start time of the second would be greater than or equal to first, and then third, then so on, right? So this is the pre-calculation for the water right, all the water rights, right? Now coming to, so if you follow the explanation part, I have mentioned there are two information required to solve this problem optimally. One was the prefix array and one was the suffix array. I'll come to this after some time. So I'll directly come to here. So here what I'm doing, I'm going through all possible land ride, right? So let's consider ith land ride. So your finish time would be start time of that land ride plus the duration. So this is the time when you finishes your ith land ride, right? So now what we have to do, we have to find out the index j where the start time of that water ride is more than the finish time. Once you do that, so this is and like to do that, I'm doing a binary search here, but not using low and high value. I just use upper bound. It will give me the exact index where the start time of the ride is greater than the finish time. So this is my index. Now once you find the index, so there are two halves, right? One half consider from index 0 to j minus 1. So for all these indexes, your start time is less than or equal to the finish for sure, because this upper bound gives you the index which is like which has the value more than your first is finish. So like from index 0 to j minus 1, they have already started, right? So once they are already started, you just have to configure the duration of that. So your answer would be finish plus minimum duration from index 0 to j minus 1, right? To find this minimum duration, I have used the prefix array. Now coming to the right half, from index j to m minus 1, they are not started yet, right? So in that case, your answer would be minimum of answer comma minimum finish time of j. So this minimum finish j essentially gives you the minimum like the minimum finish time of that water ride, and that we can get it from the suffix array. I'll explain how this prefix and suffix array are calculated. And once you do that, and I mean, so since we are we have configured all possible land ride, and for all possible land ride we have configured the most optimal water ride. So at the end, return answer. So now coming to the prefix array, this minimum duration of I essentially the minimum duration from index 0 to I. So minimum duration 0 equals to water ride 0 dot second. Second is your, so the first would be your start time, and dot second would be your duration. So these two are the standard implementation of prefix and suffix array. So I would highly recommend to learn it from the online tutorial, how to build up prefix and suffix arrays, right? And for index I to minus 1, I just updated it. So min duration of I equals to minimum of previous comma water rights of I dot second. This is my current duration, and this is my previous minimum of all the previous durations. So this is how I calculated the prefix array. Now coming to the suffix array, I have to find out the minimum finish time, right? So minimum finish time for index j to m minus 1. So since this is a suffix, we have to start from end. So minimum finish of m minus 1 is that water rides of m minus 1 dot first. Dot first is your start time, and this is your second time. Dot second is your second time. And for index I equals to m minus 2 to 0, your minimum finish would be minimum of minimum finish I plus 1, like for all, for considering all the water rights from index I plus 1 to m minus 1, or the current, so the current start time plus finish time. So yeah, this is how we calculated prefix and suffix. This is the prefix calculation, and this is your loop. So yeah, this is all about the code of the third problem. Now let's look at the fourth problem. This is the fourth problem asked in today's contest. So it says you are given an integer array nums of size n and a query array, and this query and each query will contain three information. One is the left index, one is the right index, and one is the threshold. Now for each query we have to find an answer, and your answer would be equal to the element in this subarray from this left index to right index that appear at least threshold number of times, and selecting the element with the highest frequency means for each query consider a subarray from index left to right. Now we have to find out the element which has the highest frequency, but it should be at least the threshold value. It should be at least more than the threshold number of times, right? Now so let's say if there are multiple numbers possible, we have to consider the smallest one if there is a tie, and if there is no element exists, we have to return -1, right? So like for example, your array is 1 1 2 2 1 1, right? And your first query is 0 to 5 and the threshold is 4. So for 0 to 5, 1 appear 4 times and 2 appear 2 times, and the threshold is 4, so we can only consider 1. So your answer would be 1. Now in the second case, you have to consider the subarray from index 0 to 3 and your threshold is 3. So for 0 1 2 and 3, see, the frequency of 1 is 2, the frequency of 2 is 2, but the threshold is 3, so there is no element who has the frequency more than 3. So in this case your answer is -1. Now consider the last case for index 2 to 3 and your frequency is 2. So 0 1 2 3 2 to 3, so there is just one element who has frequency 2, which is like at least 2, right? The given threshold value. So that's the only possibility, so your answer would be 2 in this case. Now to solve this problem, the exact algorithm which I have used is the square root decomposition, or sometimes it also called Amos algorithm. So this is the square root decomposition. You can learn it from CP algorithm. So I would highly recommend to learn this algorithm first, because if I explain, you won't be able to understand until you know the square root decomposition, right? So I would highly recommend to learn it first, and see, once you learn it, this is one of the standard algorithm comes in the square root decomposition. So whenever you like go and solve any problem in square root decomposition, you would always encounter some variant of this problem. So I would highly recommend to learn it first, solve one or two problem, then you can quickly write a code for this problem. This comes in a standard list of problem comes for square root decomposition. But yeah, if you want me to explain this problem and like explain the Amos algorithm, square root decomposition, and code for the fourth problem, please write a comment. I'll write a code for it and the explanation part, and I'll make a video solution for it, right? So yeah, this is all about today's contest. If you find the video helpful, please like and subscribe to my channel, and you can also share it with your friends, right? Thanks for watching.